Calc Honors students, here we are at 11.2, Geometric Representation of Complex Numbers. First, a little math history. Thank you, Jean-Robert Argand, a Parisian bookkeeper, who will give us the Argand diagrams we're about to talk about for complex numbers. Which one is he? Did you say this guy? Who, as a child, summed 1 plus 2 plus 3 up to 100 in 5 seconds? No, that's Gauss. Gauss. Carl Friedrich Gauss. How about this guy? Ancient Greek, give us a squared plus b squared equals c squared. That's Pythagoras. There you go. There's your Jean-Robert Argand. And here come our Argand diagrams. First, our objective is to write complex numbers in polar form and find products in polar form. To get there, we're going to start with Argand diagrams, which is basically the complex plane. Not the real number line anymore. That's how it starts. Here's your real numbers, as you're used to them. 1, 2, 3, and so forth. -1, -2, -3. But then on this axis, we put the complex numbers. I, 2i, 3i, the imaginary numbers. -i, -2i, -3i. And so here's your number 2 plus 3i. The complex number 2 plus 3i. But we're going to try and represent this in both rectangular form and polar form. In rectangular form, that's a plus bi, sometimes written as a comma b. Polar form is what we've been talking about with r at an angle of theta, otherwise known as r cis theta, and the cis stands for r times the cosine of theta plus I times the sine of theta. So it's called cis, cosine plus I times the sine, cosine plus I times the sine. That's why it's cis form. And if you expand this out, r cosine theta plus I times r sine theta, you see we get our conversion formulas. A equals r cosine theta, B equals r sine theta. So another note here, the absolute value of a complex number is specifically given as square root of a squared plus b squared, the magnitude r in our diagrams. Now, we saw in graphing that r could sometimes be negative, but when you report a complex number, give the r as a positive value. Now, example 1, express 2 cis 50 in rectangular form. I'm going to show you two ways to do this. First, we can go through the formulas. 2 cis 50 means 2 times the cosine of 50 plus I times the sine of 50. So it's 2 cosine 50 plus I times 2 sine 50. And you punch that up in your calculator, and you get 1.29 approximately plus 1.53 times I. Now, there's another way to do this on your calculator, and that's to look up these other values here. Let's take a look here. You can actually write 2 cis 50 as 2 at an angle of 50 degrees and put the parentheses around it. Where do you get the angle marker? Right there. And while we're at it, there's your degree symbol right above it. So 2 angle 50 degrees. And now the other thing, you might want to check on your mode. And under complex numbers, you've got 3 choices for format. You want to pick, under your complex format, in the mode menu, you have real, rectangular, or polar. Well, you don't want to stick to real, especially when you use bizarre answers when you get imaginary answers. So pick rectangular, and then your answers entered like this, 2 at an angle 50, will just show up in rectangular. You can also choose polar if you want all your answers to end up in polar. There's also, in the catalog, look under P's, there's a convert to polar key, and also a convert to rectangular key under R's. So that's another way you can deal with these. Now express -1 minus 2i in polar form. Let's look at the visual approach to it first. X-axis here. Here's our Argand diagram. -1 minus 2i. So where are we on that one? We're down here. -1 minus 2i. And so we can come up with a magnitude as the square root of -1 squared plus -2i quantity squared. A lot of kids mistakenly put the I inside here. Oh, no, no. It's just the coefficients A and B that you use in this formula. You get 1 plus 4, so you get the square root of 5 for the exact magnitude. That's this length like this. And now we want the angle. Well, the angle comes all the way around like that. The tangent of the angle will equal B over A. So that's -2 over -1 is equal to 2. So theta will equal the inverse tangent of -2. Now, the answer of 2, positive 2. Now, your calculator is going to give you basically the wrong answer. It's going to tell you 63 degrees. You have to look at your diagram to say, oh, this is 180 degrees beyond 63 degrees, so the angle we want is 63 plus 180, or 243 degrees. So our answer then is square root of 5 and an angle of 243 degrees for polar form. You could also say square root of 5 cis 243 degrees. You could also calculate out the square root of 5, 2.24 cis 243 degrees. Okay? Now, again, you can do this by using convert to polar on your calculator. In the TI-89, you can say, okay, there's the I there above catalog. You can actually enter -1, -2, and then use this I. Don't use the I down here, or even if it's lowercase. You want this italicized I as the square root of -1. And then use the old convert to polar key, and you're right there. Now, a lot of times I'm not going to want to calculate an answer, so we'll go over how to convert these. But first, let's talk about the product of two complex numbers. Here's the formula. Two complex numbers multiplied together in polar form, R cis alpha times S cis beta. You multiply the magnitudes and you add the angles. Why? Well, let's go through the proof. First of all, let's expand out what R cis theta means. It means R times the cosine of alpha, in this case, plus I times the sine of alpha, multiplied by S times the cosine of beta plus I times the sine of beta. Now I can reshuffle these with the associative property multiplication, say R times S times, now I'm going to multiply these out with FOIL. Remember FOIL? First, outer, inner, last. First would be cosine alpha, cosine beta. Outer would be, outer would be I times cosine alpha sine beta. Inner would be sine alpha cosine beta times I. And last would be I squared times sine alpha sine beta. So now we can put together the real parts. That's cosine alpha cosine beta. And then this I squared becomes -1, so it's minus sine alpha sine beta. Plus, factor out the I from these two, and we get sine, sine alpha cosine beta plus cosine alpha sine beta. All right. And so we have RS times the cosine of alpha cosine beta minus sine alpha sine beta. We just did that expansion. That's the cosine of alpha plus beta plus I times sine alpha cosine beta plus cosine alpha sine beta is the sine of alpha plus beta, which works out to be RS cis cosine plus I times the sine of alpha plus beta. Very handy. It's going to make multiplication in polar so much easier. So let's express all these in polar form and graph all three in the complex plane. Now, rather than use my calculator in this one, these involve special triangles, so you should be able to do this readily. So let's make our complex plane. And our first number, Z1, is 3 plus 3i. So 1, 2, 3, up 3. Here's 3 plus 3i. Clearly you're going over 3 and up 3, you've got a slope of, that's a 45-degree angle. So Z1 equals 3 root 2 at an angle of 45 degrees. See how I did that conversion visually by thinking about the special right triangle. 45, 45, 90. Now 1 plus I root 3. Now we're going to go over 1 and up square root of 3, so that's about in there. 1 plus I root 3, so you're going over 1, up square root of 3, that's the 30, 60, 90, so that's 60 degrees, and this magnitude is 2. So Z2 equals 2 at an angle of 60 degrees. Okay? So now, to do Z3, the product, Z1, Z2, we can just take the product of the magnitudes, 3 root 2 times 2, and sum the angles, 45 degrees plus 60 degrees. So we get 6 root 2 at an angle of 105 degrees. 6 root 2 at an angle of 105 degrees. So here's our 105 degrees, and there's your 6 root 2. Okay? I should say at an angle of 105 degrees. Now notice if you tried to do this in rectangular, you could. You'd have to go ahead and use foil. And sometimes whether you use polar or rectangular depends on what kind of form they're in and what kind of form you want at the end. So 3 plus 3i, that was our first number, times 1 plus I root 3. We can go through foil. First, outer is 3i root 3, inner is 3i, last is 3 squared root of 3i squared. So you get 3 minus 3 root 3 plus I times 3 root 3 plus 3. Okay, that would be the exact answer in rectangular. So, now that comes to the question, should we multiply in polar or rectangular? For here's an example, 2 cis 50, 3 cis 20. What do you vote for? Okay, I'm sensing your votes. Polar wins, definitely. Notice I didn't specify form. Maybe if I'd said I want the final answer in rectangular form, but even in that case, with these two being in polar already, let's multiply them in polar. 2 times 3, multiply the magnitude, cis 50 degrees plus 20 degrees. And so you get 6 cis 70 degrees. It's that easy. And you know, even if I ask for the answer in rectangular, now it's easy to convert this 6 cis 70 into rectangular. Notice, let's look at those of you that voted for rectangular. You got to convert in rectangular. I did that conversion on the calculator. I multiplied them using FOIL. There's that I squared. Added up the real parts, add up the imaginary parts, and finally convert back to that. A lot more work. Okay? Flange out.